Hello and welcome to the data activity videos. So a few things about StatCrunch and datasets. So first of all, you should look in the how to find my datasets document, and that will always have the most updated way how to get into the datasets and everything. And we're going to go through this as well. However, they like to change this direction like every few, seems like weeks. So it may not be the same in the video, but this document will always be as updated as possible. So log into StatCrunch, and you can go into StatCrunch either through www.statcrunch.com or go in through My Lab and Mastering. Once you're in, and I'm logged in as Bo Corkins here, and so you can go into StatCrunch, and that's where we'll do our analyzation. But the very first thing is how to find the data sets. The data sets that we use for activities, quizzes, and the lectures. You want to go in here, you go into data sets, and then you search, and then type in Bo Corkins. Hit enter. And that's it. Then there are 8 pages of data sets, and they're all here, all right, of varying types of data sets, and it's that easy to find the data sets. All right, so I want to look at some information, and specifically one other big thing is, again, how to copy to a Word document. So let's look at the political parties data set. And so in order to make graphs, it's very, very straightforward. Pie charts, bar charts, you go in, you hit select pie chart, and then depending upon what you're given with summary or with data, in this case, I actually have the summary because I have the counts. I don't have the individual data values. Notice it says I have young Republicans, I have 241 of them. If that was the actual data, there would be 240 data values representing that, then 299 representing middle-aged Republicans, all right? So I have the summary, so pie chart with summary. Then I go in here and it doesn't matter, we're just gonna do it by age, counts and count. Depends upon what you're looking at. We're not looking at anything specific here. And then hit compute. Now I could title this and do other things as well, but I really just want to focus on how to copy this into a Word document first. So you select copy, all right, it says right click the image below, right, and notice right click the image, copy the image, and when you hover over this, it says, all right, Control-Alt-V and paste as device independent bitmap, all right, so by far, that's the biggest issue I see. So we go in here, I can go here and then Control-Alt-V, device independent bitmap, and hit OK. And oh, look, there is the graph that I just had. So by far, the biggest issue I see with people is they can't seem to get their graphs, but that's how you do it. All right, and that's all laid out right there. So I want to actually look at the Titanic data set, and we can look at analyzing things. And I have it all laid out here in the document, which you can look through. So I'm going to graph the bar. I want to graph a bar chart, right, and a pie chart, just like I just did, all right. And they're both going to be with summary as well, all right, because we're going to have the counts dependent upon the data. All right, so go back to shared data sets. I'm going to go back to page 1 here, where the Titanic data set is, Titanic. And once again, all right, notice that the data is represented. There's two different categories, class and survival, and the counts of that were in each category. And we go in here, graph, select bar plot with summary, and we can do it with class or survival. We'll do it with class here. And you have some other options. Again, you can change the colors, but we're just doing basic graphing here, nothing fancy. You can also change it to relative frequency, put it in percentages, value ascending. And this gives us, all right, just the class, just the classes that were in the sections. And we have it on relative frequency. That means this is the probability. So there's about 15% in first class, 13% in second, 40% crew, 34% in third class. So very simple. Also, go in here. If you go back to edit, I could put a title on here. I can label the axes. All right. I could change this to vertical versus horizontal. There's all kinds of little details, but again, for the basic concept, it doesn't change. Every time the basic concept remains the same, that this is a bar chart. Similarly, I can do that same concept to create a pie chart. And pie charts are really nice because they sum everything to 100%. That's a really helpful aspect. Also, if you notice, they give both the counts and the percentage and color align it. All right, so pie charts are what we tend to do more because it creates what we call a distribution, right? Distribution is how things are broken down and summing to 100%. So everything summing to the total, all right? So pie charts very helpful. Very nice graphical displays, very clear. What is a big question that we want to look at as well is not just how to create regular pie charts, all right? Oops, like I did here, marginal displays, all right, regular pie charts, but conditional displays. Conditional pie charts, all right, make use of the where statement. That is given, all right? Given a particular situation. And so this, again, pie chart with summary, class, counts and counts. Now where, and I'm going to say survival equals alive. Now, very important, it's case sensitive here, all right? And the title of the column has to match the one of the categories within that column. And it actually auto titles this, but I'm going to reinforce that. And I'm going to say class given alive. And notice, see, it says survival equals alive there. I'm going to make another one so we can actually compare this, because this brings up a big point we have been emphasizing, which is independence and dependence. So very similar here, instead of survival equals alive, survival equals dead. Again, it has to match one of the categories within the column. And this is very nice because these are now conditional displays, all right? This given, all right, those who died, those who lived, all right, on the Titanic, their class breakdown. And basically, this is the best part. In order to identify independence, you just compare these. Is blue equal to blue? Is yellow equal to yellow? Red equal to red? Green equal to green? Looking at the pictures, they are clearly not. So from a first glance, when the pictures are not the same, they are dependent. However, we go a step further and we are going to compare specific probabilities and write them out in probability statements. So I grab a color. I'm going to compare blue to blue. Is 45%, 45.17% equal to 29.82%? And I've already done that for us here. is the probability of crew given dead equal, question mark equal, to the probability of crew given alive? Is 45.17% equal to 29.82? These are clearly not equal, so class and survival are dependent events. This is by far one of the biggest pictures that we create and one of the most important concepts we try and emphasize when analyzing data and probabilities is there an association between, all right, two given categories, right? And we talked about it before. Yes, all right, most of the time, all right, if you are guessing, you should guess they are related. Most things in the world are related. So independence and dependence, big concept. We've been talking about it for a while. This is another way to prove events are either independent or dependent. So also as a note, we can use another graph, the Titanic table graph. And so I need another data set here. I'm going to go to the Titanic table data set. And notice the data set is laid out differently here. The data set isn't entered column-wise, where things are entered down the column, all right? But things are entered just like a contingency table. Now, we only, most of the time, 95% of the time, enter your information column-wise. That's how you analyze it because you make graphs. However, just as a note, if you go into stat, summary stats, stat tables, contingency, and again, with summary, then I'm going to select my columns. The row label is survival, my columns, and control click. And then I'm going to select row, column, percent of total, and hit compute. And this gives me lots and lots of information. So what this did is this calculates conditional probabilities in here. And this calculates conditional probabilities, all right, automatically for us. This is a really, really nice way to quickly calculate some conditionals. So for example, the row percentage here, this is the probability of first given alive. That's the 203 out of the 711 because it's the row. So it's this number out of this number. Then this next value is the column percent. That means it's the 203 out of 325. And then percent of the total, it's 203 out of the overall total, which is 2201. So this, if you enter data this way, it gives you a fast way to calculate values. However, it tends not to be the way we go to, and I'm going to show you that usually we just look at the printed out contingency tables, and you can do most of this just by visually inspecting. You actually don't need the technology for this. We definitely need the technology to create pie charts and bar charts and such. So that's why we tend to enter our information column-wise like we have here. All right, we'll investigate more about this in the next video. Thank you very much.